Thank you very much. I'm Geoffrey Brown, professor of computer science here, and Paige pointed out that this part of the background kind of applies to what I'm going to talk about, which is circuits. I've been working with some biologists at IU for the last couple of years on developing very small data loggers to put on songbirds. These are birds that weigh about an ounce or less. My main collaborators in biology are Adam Finneker and Ellen Catterson. And within the school, Bryce Heimbaum's had an important role to play in this. And then what I really want to point out is the bottom line there, which is our undergraduates who've worked with us. This work really wouldn't be possible in this environment without strong undergraduates. There are many, many activities that we do that involve undergraduate research. For example, Dylan Gagon's in biology, and he's been doing our actual flight tests, flying loggers on birds in captivity. Xiaowei Chen is an undergraduate here who's done a lot of the software development work at the sort of user interface level. And then Zach Marvel is now graduating, and he's been doing a lot of work on embedded software design. So here's the opportunity from the biologist's perspective. If you look at the distribution of the size of birds, what you find is a lot of birds don't weigh very much. And the birds that our collaborators are interested in are juncos. They're particularly very common songbird. They've been used for many years as a model species by biologists. And they weigh between 20 and 25 grams. And based upon sort of the accepted standards in biology, that means you can put something on them that weighs about a gram. And if you're going to live in the 1 gram space, as I'll show you, you also have to live in an extremely low power domain. There's not a lot of energy you can carry. So we'll talk about that a little bit. So in a sense, the goals of this project were set by the model species. As it turns out, it's extremely difficult to do this, say, at half a gram. And I'll show you why in a minute. But 1 gram seems to be just about what you can do with off-the-shelf technology. Now, we're not doing anything that involves custom circuit design. This isn't a high-dollar domain in which biologists have millions of dollars to spend on developing circuits. What they want is to buy 25 loggers. And they don't want to spend $10,000 a logger. They want to spend $100 a logger or less. So there are engineering constraints here that have to do with the scale of the audience, so to speak. This is a junco. I know almost nothing about birds. You probably know more than I do about birds. I know that David knows a whole lot more about birds than I do. And they're important to biologists. They're the first model species. They're the species that was used to determine that birds use length of day as a cue for migration. And that goes back to the 1920s. And they have, they thrive in captivity, that's awesome. And they're actually a very diverse species. There are many subspecies. So here, this slide captures the sort of fundamental problems that we're dealing with. If you're going to design something to put on a bird this small, it obviously has to be very small. And there are really 2 constraints. There is the constraint of how you pack the electronics together. And if you're willing to throw a lot of money at the problem, you can pack it a whole lot smaller than we can. But the other constraint is energy. This is the smallest commercially available battery that can provide the peak energy that you require to do things like writing to flash memory. It's a lithium polymer battery. It weighs roughly 0.3 of a gram, and it stores 8 milliamp hours. And so I have on the slide, a few little points of reference, but the most important thing is if you want this to last, say, a year, that means you have to operate below a microamp, which is extremely low power if you know much about electronics. To give us kind of a scale, there's a picture of a board there. Oh, I'm going to move on because I'm running out of time. I want to show you a movie of our first test flight, and this gives you a sense of what we're trying to accomplish here. This was done by the undergraduates. Let's see. Expand this a bit. I'll restart it. What you see is a bird flying. Xiaowei Chen did the motion tracking on the bird, because it's one of the things you have to do is get ground truth, and so tracking the bird is difficult. Below, you see the output of accelerometers. And what we have found is the accelerometers have very low noise in this context. You can see that when the bird's really not moving, there's almost no activity in the data below. And when the bird's flying, you can really tell it's flying from the accelerometer data. So that was good news for us. Where we're headed now is looking at ways to save energy. So all those idle times, you'd like to not be powering things that you can manage it. And for the biologists, identifying activities, because they're interested in seeing how active the birds are when they're active, what kind of activities they engage in. And the kind of activities you can detect are flying, hopping, small things like that. Thank you very much.